Welcome to a new episode of the podcast. Vox Agent is made by AI for business executives that work with AI. Today we're taking a deep dive into an absolutely critical emerging discipline in enterprise security, identity and access management for autonomous AI agents. Now you might be thinking, we already have security for our systems, but securing these new digital coworkers, these intelligent AI agents, it requires a fundamental shift. Traditional security approaches, designed for human users with static roles, they simply aren't enough when AI changes context rapidly and performs tasks without direct human input.
Precisely. Our mission for you, our listener, is to gain a clearer view of how businesses are safely harnessing AI's immense potential. This deep dive will reveal how organizations are moving beyond those traditional methods to dynamic identity and zero-trust frameworks, specifically tailored for AI agents. We'll be focusing on things like fine-grained authorization, continuous verification, and context-aware access controls. It's a foundational change, really, in how we establish and maintain trust in the digital age.
So let's unpack this a bit. What exactly is an AI agent in this context?
Yeah, good question. Think of an AI agent as an autonomous software entity. It's often powered by advanced AI or maybe a large language model, and it can initiate actions or requests on behalf of users or even other systems. The core challenge here is that for human users, we typically manage identities with, static roles and credentials that often live for a long time. But AI agents, they completely defy these traditional assumptions. They're not just another employee logging in.
Right. And why does that dynamic nature cause traditional identity and access management, IAM, to falter? Why does it break down?
Well, because AI agents are incredibly dynamic. I mean, they can spin up or down in seconds, they can assume different roles for each specific task, and crucially, they operate without direct human intervention. This creates a fundamental mismatch with traditional IAM that assumes static identities, predetermined roles, and usually just a one-time authentication event. Imagine trying to use a system built for, say, a fixed-hours employee to manage a self-driving car that needs to make real-time decisions, constantly adapting its access based on road conditions or traffic. It just doesn't fit. Traditional systems simply lack the real-time adaptability required by AI. They might grant access for way too long, or maybe not adjust when an AI's mission or risk profile changes, creating some pretty dangerous vulnerabilities.
So once a traditional system authenticates something, it often just assumes it's trustworthy for the whole session. That sounds like a dangerous assumption with AI.
Absolutely. With AI, that assumption is inherently risky. An agent might be hijacked, right? Or it might encounter totally new scenarios that require additional checks, unforeseen ones. Plus, AI agents often need to change roles on the fly. An AI assistant could, in one moment, be reading calendar data, pretty low risk, read-only in the very next second, need to send an email on behalf of a user. That requires a completely different set of elevated privileges, maybe just for that one action mid-session. Traditional IAM expects a user's role to be relatively constant. That just doesn't work for the fluid nature of AI.
Okay, so this explains why organizations are rapidly shifting towards dynamic identity management and these microsegmented zero-trust frameworks specifically for AI agents. It's a new principle, essentially. Treat AI agents as dynamic, potentially high-risk identities that have to earn trust continually, which is really the essence of applying never trust, always verify to every single action an AI agent takes, right?
Exactly. And to address these challenges, organizations are adopting several core concepts. First up is fine-grained authorization. This means access control decisions are made at a very, very granular level. We're talking using a rich set of attributes and context rather than just broad general roles. It's a big departure from simpler role-based access control, RBAC, moving towards things like attribute-based access control, ABAC, and policy-based access control, PBAC.
So they only get exactly what they need, precisely when they need it, maybe even down to the specific data field or API call.
Precisely. An AI agent's access might depend on its specific purpose, the sensitivity of the data it's trying to touch, the time of day, or even a real-time risk score that's constantly being calculated. Imagine a policy saying something like, okay, this agent can only access non-sensitive healthcare data and only during business hours because its function is defined as healthcare bot. This ensures the principle of least privilege is maintained basically all the time. Next concept is ephemeral authentication. Because many AI agents are short-lived, or maybe they perform transient tasks, using long-term credentials like stored passwords or static API keys is both risky and, frankly, impractical. Ephemeral authentication means issuing credentials or identity tokens that are very short-lived. They're scoped to a specific task or a narrow time window, and they automatically expire.
That sounds like a major step. It really minimizes the potential damage if credentials somehow get compromised, doesn't it?
It's crucial. It minimizes the blast radius, as we say, from credential leaks, and ensures agents don't just accumulate unnecessary privileges over time. It ties directly into just-in-time, or JIT, access. Privileges are granted just in time for the task and revoked immediately after use. Think of it like a temporary keycard, a token valid only for one specific database query, active for maybe just a few minutes, and then poof, it's gone. And that brings us naturally to real-time trust scoring. Unlike humans, where a single login might be considered enough trust for a while, AI agents can and should be continuously evaluated. A real-time trust score is essentially a dynamic rating of an agent's trustworthiness based on its current behavior and context. So if an agent starts behaving anomalously, say it suddenly tries to access resources it's never touched before, or attempts unauthorized actions, its trust score can drop instantly in real time, triggering immediate restrictions.
Wow. So it's like a continuous self-adjusting risk assessment running constantly.
Exactly. A high trust score, earned by consistent compliant behavior, might grant broader access within its defined limits. But any suspicious activity instantly curtails those permissions or might even trigger a full revocation. It's very similar to continuous adaptive risk assessment, CARTA, concepts, but applied at machine speed specifically for these autonomous agents.
That's a huge shift from static permissions. Okay, so how does this actually build? What are the architectural components needed to enable this continuous verification in these fine-grained decisions?
Right, let's get into the architecture. At its foundation, you need an agent identity provider, or IDP. Its job is to establish and verify the AI agent's identity in the first place. This system needs to be capable of issuing these ephemeral credentials at massive scale. We could be talking thousands of short-lived tokens per second, things like JSON Web Tokens, JWTs. These are like secure, tamper-evident digital passports for the agents, and they often embed metadata about the agent's task, its owner, its allowed scopes. Crucially, authentication here isn't a one-time event. It involves continuous verification mechanisms, things like periodic challenges, maybe requiring the agent to prove its integrity, and very short token lifetimes requiring constant refresh. If an agent's real-time trust score drops, the authentication service might reject its next request or demand stepped-up authentication. Then comes the policy decision points, the PDP. You can think of this as the brain of the fine-grained authorization system. Every request an agent makes to access a resource gets vetted by the PDP. It uses policies that evaluate attributes like the agent's verified identity, its current trust score, the resource being accessed, the context, and any detected anomalies. Policy engines like Open Policy Agent, OPA, or maybe Cerbos are often leveraged here to manage these complex roles.
Okay, in the PEP, the policy enforcement point, that's the component that actually puts those decisions into action, the muscle, so to speak.
That's right. The PEP intercepts the agent request maybe at an API gateway or a service mesh proxy, or even within an application's SDK, and it enforces the PDP's allow or deny decision. PEPs can do more than just block. They can sometimes mask or redact sensitive data fields based on the policy, ensuring very granular control over what the agent actually sees or does. A robust architecture involves a distributed network of these PPs to protect every possible entry point. Beyond that, continuous monitoring and anomaly detection are absolutely crucial. Security analytics platforms watch agent actions looking for unusual behavior. Like, is an agent suddenly trying to read 1,000 files when its baseline is 10? Or accessing systems at odd hours? This feeds directly back into the real-time trust score, dynamically adjusting access or even triggering alerts and credential revocation if needed.
And if things go really wrong, despite all this, what's the panic button or the emergency brake?
Good question. That's where global session management and revocation comes in. This provides a centralized, unified view of an agent's session across the entire environment, even if it's interacting with multiple systems. If an agent's trust score plummets or it definitively violates a critical policy, this system can instantly revoke all its active credentials organization-wide. It essentially shuts off the agent in real time. This capability is absolutely crucial for rapid incident containment, minimizing damage quickly. And for more complex scenarios, like agents from different organizations needing to interact securely, things like identity federation and naming services become important. The Cloud Security Alliance, for instance, is doing some interesting work prototyping an agent naming service. Think of it like a DNS, but specifically for agents, holding their verifiable credentials for secure discovery and interaction across organizational boundaries.
So this entire architecture, it really is intrinsically zero trust. Every single move an AI agent makes is subject to scrutiny. Nothing is trusted by default. Okay, that's a lot of technical detail. Why should our listeners, the business executives, really care about all this? What are the tangible benefits for their businesses?
Oh, the benefits are profound. Let's start with the most obvious. Dramatically reduced security risk. Fine-grained, least privilege access fundamentally minimizes the potential blast radius of any security incident involving an agent. There's IBM research showing organizations with mature zero-trust practices save, on average, over $1 million in breach costs. That's significant. And consider this striking statistic we found. 72% of organizations believe AI agents pose a higher security risk than normal machine identities, and almost a quarter, 23%, have actually witnessed AI agents being tricked into revealing credentials. These controls directly address those very real vulnerabilities.
That's compelling. And what about regulatory compliance? That's always top of mind.
Absolutely vital. A robust IAM framework for AI agents significantly improves compliance and accountability. Tightly governing and logging access to sensitive data helps meet stringent regulations like GDPR, IPA, PCI DSS, you name it. You gain a detailed, auditable trail. This helps demonstrate compliance with emerging regulations like the EU's Draft AI Act, and it allows you to enforce segregation of duties, preventing an AI agent from, say, both initiating and approving a sensitive financial transaction. This also directly enhances operational efficiency and resilience. Automation, like the ephemeral and just-in-time access we talked about, reduces the administrative workload on security teams and cuts down on human error in managing credentials. Perhaps more importantly, having strong, verifiable security guardrails lowers executive hesitation. It builds confidence, enabling greater AI adoption across the business. Think of a bank confidently using AI for complex trading strategies because they know the AI operates within strict, enforceable policy checks. Those guardrails are demonstrably in place.
Right, and that improved visibility leads to better incident response too, doesn't it?
Precisely. You get finer risk management and incident response capabilities because the granular logs provide excellent visibility into exactly what an agent did, when, and why. Rapid containment through things like global revocation, shutting an agent down in seconds, and detailed forensic analysis become much more achievable. You can isolate an incident quickly. But ultimately, this isn't just about mitigating risk. It's about business enablement and agility. Security, when done right for AI, becomes an enabler for innovation. It allows you to confidently deploy AI in sensitive core business areas, leading to new products, better customer experiences, or significant cost savings. Picture a healthcare provider safely using AI to summarize complex patient records, improving doctor efficiency while strictly adhering to APA.
Those are really compelling benefits. Let's maybe dig into some more concrete use cases. What does this actually look like in the real world across different industries?
Sure. In financial services, for example, AI agents can assist with algorithmic trading, but they execute trades only within precisely defined risk limits, perhaps requiring human approval if certain thresholds are breached. Or think about fraud detection. An AI agent might have read access only to masked customer data, analyzing patterns and blocking transactions based on a high fraud confidence score. We know firms like JP Morgan are actively piloting AI in these areas with strong controls.
And healthcare you mentioned, where patient data is incredibly sensitive.
Yes, healthcare is a prime example. AI agents can sift through vast amounts of medical records to identify potential drug interactions, suggest diagnoses based on symptoms, or even automate appointment scheduling. Fine-grained controls are absolutely essential here. An AI agent might be restricted to only retrieving the specific patient records requested by an authenticated doctor. Or maybe an ephemeral token is issued that expires after just one database query related to a telehealth session. A telehealth AI triage assistant, for instance, can gather initial patient symptoms safely, handling thousands of interactions per month, significantly reducing the workload on nurses while maintaining privacy. In manufacturing and the Internet of Things, IoT, AI agents are increasingly used to control physical machines and robots on the factory floor. Here, microsegmentation and fine-grained authentication are critical for safety. They ensure that commands sent by an AI agent are within established safety parameters and adhere to approved production schedules, preventing hazardous or unauthorized machine operations. Think of an AI scheduling agent optimizing an automotive assembly line.
Makes sense. And across the whole supply chain, managing logistics must involve many interactions.
Indeed. In supply chain and logistics, AI agents can coordinate complex deliveries, predict delays, or dynamically reroute shipments across partner systems based on real-time conditions. Dynamic identity trust is key here. Imagine a large logistics company like DHL allowing a customer's AI agent limited temporary access to a tracking API, but only for that customer's specific packages. This streamlines operations safely without exposing unnecessary data. And looking even broader, for cross-industry collaboration, you might have multi-agent systems where AI from different companies need to work together on a common goal, like a large-scale construction project involving architects, engineers, and suppliers. A central policy hub could enforce granular access rules, ensuring each company's agents only see the data relevant to their specific tasks, enabling secure automation of complex cross-company workflows that might otherwise be impossible due to trust and data sharing concerns. The pattern is clear. Fine-grained, context-aware access allows AI agents to operate securely and effectively in highly sensitive domains, ultimately improving care, safety, efficiency, and collaboration across industries. Now, while the vision we've described is quite ambitious, it's important to note the industry is currently in its early phases. But there's a real flurry of activity and rapid progress happening right now.
That's exciting. So what's the current state of the art? Who's doing what in this space?
Well, you've got the established IAM vendors, think Okta, Ping Identity, Microsoft Entra. They're rapidly extending their existing platforms to cover AI agents. Their goal is often a single control plane managing both human and non-human identities, trying to prevent AI from becoming an identity blind spot. Their strength lies in integration with existing enterprise infrastructure and governance. We also see the zero trust security and privileged access management PAM vendors, companies like Zscaler, Palo Alto Networks, CyberArk. They're approaching it from the network and privileged access angle, securing traffic, microsegmenting, and adapting PAM controls for these non-human identities. Then you have a growing number of emerging startups. Companies like Strata Identity focusing on identity orchestration for AI, or Cerbos providing sophisticated policy engines. These players are often innovating quickly on specific niche problems, and of course the major cloud providers AWS, with things like Cognito and Verify Permissions, Azure and GCP, are all building tightly integrated, often cloud-specific solutions within their own ecosystems.
It really sounds like almost every large organization is planning to increase their AI agent use significantly, which must be driving huge demand for these kinds of solutions.
Absolutely. This trend is essentially creating a new market category, often called non-human identity management. We're also seeing a crucial intersection with traditional identity governance and administration, or IGA, from vendors like SailPoint. They're extending their governance capabilities to ensure proper oversight, auditing, and attestation for these AI accounts, just like we do for human employee accounts. This market is definitely set to grow sharply in the coming years.
Okay, so if we look ahead a bit, say 3 to 5 years out, what are some of the really exciting emerging trends we should anticipate in this space? What's on the horizon?
Oh, there are several really interesting developments. We'll likely see decentralized identity, DIDs, and verifiable credentials, VCs, become much more mainstream for agents. This means AI agents could get portable, cryptographically verifiable global identities, which would significantly improve secure collaboration between agents from different organizations. The Cloud Security Alliance is already prototyping frameworks for this. Real-time trust scoring and reputation systems will also evolve significantly. Imagine federated reputation scores for AI agents, allowing them to assess the trustworthiness of other agents they need to interact with. AI-driven risk engines watching over other AI.
Wow, a reputation system for bots. That's a big step for establishing trust in complex automated systems.
Indeed. We'll also see major advancements in privacy-enhancing technologies, PETs, things like homomorphic encryption, secure multi-party computation, and especially zero-knowledge proofs, ZKPs. These technologies could allow agents to compute on sensitive data or prove they're complying with policies without ever exposing the raw information. That's a potential game changer for data privacy and meeting regulatory requirements. We'll also see more focus on secure multi-agent systems, developing conversation-level authorization. So agents working in teams have constraints not just on data access, but on what information they can actually reveal to each other during collaboration. And we can definitely expect standards and frameworks from bodies like NIST, ISO, and various industry consortia to mature, which is crucial for improving interoperability between different vendor solutions and platforms.
So are you saying we might see AI-assisted security specifically for AI itself? That sounds like layers of intelligence working together.
Right, exactly. Imagine AI systems that dynamically adapt security policies for other agents based on observed behavior, or AI that detects novel attack patterns targeting agents, or even AI automating parts of the incident response process for compromised agents. We might even see the emergence of cross-organizational AI collaboration platforms, secure marketplaces or brokers that facilitate and govern interactions between agents from entirely different companies. And looking even further out, the ongoing push for quantum-resistant algorithms will be critical to future-proof AI agent identity and credentials against the threat of quantum computing. Finally, expect a significant regulatory push and focus on AI governance. Regulations will increasingly mandate specific controls for auditability, explainability, and crucially, the ability to reliably disable AI actions if necessary, as we're starting to see with frameworks like the EU AI Act.
What stands out most to you about this future landscape? For me, it feels like these innovations are fundamentally transforming how we think about AI trust and security, moving us towards a much more capable, but also verifiably secure digital ecosystem.
That's a good summary. However, while it's all very promising, implementing these advanced controls presents some very real challenges for organizations today. One major hurdle is simply policy complexity and management. We're talking potentially hundreds or even thousands of highly granular rules. This can quickly lead to what we call policy sprawl, an overwhelming tangle of permissions that's incredibly difficult to manage, audit, and can inadvertently create new security gaps if not handled carefully. This really requires skilled personnel and robust governance processes, maybe even treating policies as code with proper version control and testing.
And I imagine integrating all this with existing, maybe older systems can be a real headache.
It absolutely can be. Integration with existing systems, especially legacy applications, is often a significant hurdle. Retrofitting these fine-grained, context-aware controls into applications that weren't designed for them can be difficult, expensive, and might introduce performance concerns or latency. Think about an old mainframe system an AI agent needs to interact with. You might have to build complex API layers or proxies in front of it, adding complexity. We also face tooling and visibility gaps. Many current security monitoring tools aren't really tuned yet for the specific behaviors and potential anomalies of AI agents. This makes it hard to differentiate malicious activity from legitimate, but perhaps unusual, agent behavior. Debugging issues across this distributed system can also be quite complex, and the scalability and performance requirements are immense. The underlying infrastructure, the IDPs, the PDPs, the logging systems must be able to handle potentially thousands, maybe even millions, of real-time authentication and authorization checks per second without becoming bottlenecks themselves.
Sounds like there are probably cultural challenges, too, getting different teams on the same page.
Definitely. Cultural and organizational challenges are often just as significant as the technical ones. A real mindset shift is needed. You need much closer collaboration between the AI development teams, the business units using the AI, and the security teams, breaking down traditional silos. You also need to address the emergence of shadow AI agents being deployed without proper security oversight. Furthermore, there's the persistent risk of non-human identity sprawl. That's the accumulation of untracked or poorly managed AI identities whose credentials might outlive their usefulness, creating dormant attack vectors if not properly governed and decommissioned. And finally, as we touched on, cross-domain trust and interoperability remain a challenge. Without mature standards, enabling secure interactions between agents from different organizations often requires complex, bespoke, and potentially insecure integrations.
Okay, so acknowledging those challenges, what does this all ultimately mean for you as a business executive? These aren't insurmountable, clearly, but they definitely require strategic planning and investment.
Right. From an executive perspective, embracing these measures fundamentally enhances your overall security posture. It proactively closes a significant and rapidly growing security gap by treating AI agents like the powerful digital employees they are becoming. This directly leads to fewer breaches and reduced risk. It also leads to improved regulatory compliance and governance. Having these controls helps you meet strict data access regulations and provides the detailed audit trails needed to demonstrate compliance and responsible AI usage. But beyond defense, this framework becomes a powerful enabler. It allows your organization to pursue AI-driven innovations safely and confidently, deploying AI into core business processes where the value is highest, but the risks were previously too great. And in some cases, having demonstrably advanced AI security can even become a differentiator, a new business opportunity. It can be a selling point that builds trust with clients, partners, and regulators.
That makes sense. So for our listeners who are thinking, okay, this is important, where do I start? What are some concrete next steps they can take today?
Good question. First, start with an inventory and risk assessment. You need to understand what AI agents you already have, which ones are in the pipeline, where they operate, and what data they access. This helps you prioritize where controls are most needed. Then, pilot a solution. Don't try to boil the ocean. Start small, maybe with a specific high-risk or high-value use case in a controlled environment. This lets you build internal expertise and demonstrate the value quickly. Definitely engage vendors and experts. Talk to your existing IAM and security vendors about their roadmaps for non-human identity. Consult with specialists and leverage emerging industry frameworks from organizations like the Cloud Security Alliance or NIST guidance. Internally, you need to update your policies and standards. Make sure your corporate security policies explicitly address non-human identities and AI agents. Define clear ownership and responsibilities. Prioritize training and awareness. Educate your IT teams, your security operations center, and crucially, your business unit leaders who are sponsoring AI projects on these new concepts and risks. Then, plan to iterate and scale. Based on your pilot learnings, gradually integrate these practices and technologies into more projects and across more of the organization. And most importantly, this really requires leadership and vision from the top. Champion AI security as a foundational element of your overall AI strategy, not just a technical afterthought or compliance checkbox. In summary, fine-grained authorization and zero trust principles applied to AI agents, they aren't just fancy security tools. They are truly foundational enablers of the future AI-driven enterprise. They are what will allow us to unlock AI's vast potential safely, responsibly, and confidently.
That's a great way to put it. This path really ensures that AI agents can become trusted, valuable coworkers, not unpredictable wildcards of uncertainty in our systems. So as AI agents become increasingly ubiquitous, consider this question. What new possibilities truly open up for your business when every single AI interaction is not just efficient, but also verifiably secure and fully accountable? How will you lead your organization in building this future of AI, one that is both incredibly innovative and deeply demonstrably trustworthy? Thank you for joining the podcast, and see you soon.